All right, today's lesson is on special triangles, and I know it just seems like we keep reviewing geometry, but I tell you, these things are important. Let's take a look at a classic 45-45-90 or right isosceles triangle. So a right isosceles triangle or 45-45-90 is a triangle that has two congruent legs, and then we have the hypotenuse opposite the 90 degrees. So we know this is congruent to this. I'm sure you may remember the relationship between the three sides, but let's derive it anyway just for fun. So we know the two legs are congruent. So I'm going to call this leg, I'm just going to use the variable house. It's my favorite variable. You'll see it in more and more videos I create. But we have a house here, which means we have a house here. House can be anything. It can be a number, it can be an expression in terms of x, which is why I like it better than x, because it could be an x squared plus 2x plus 5 or whatever, but we'll just call it house. We know that in any right triangle, that the square of this side plus the square of this side is equal to the square of this side. You know that better as a squared plus b squared equals c squared. So I will call this side a and this side b, and I get house squared plus house squared equals the hypotenuse c squared. House squared plus house squared is 2 house squared, and that's equal to c squared. We can now take the square root of both sides and get the square root of 2 house squared equals the square root of c squared. The square root of c squared is c. The square root of 2 is an ugly number, so I will write it as the square root of 2. And the square root of house squared is house. We'll clean this up and rewrite it as house root 2, and that's equal to c. So you may have seen this before. I hope you have. We can talk about the sides of a 45, 45, 40, 45, 45, 45, 45, 90, or a right isosceles triangle as house, house, house root 2. The hypotenuse being multiplied by the square root of 2. A way to remember that, the square root of 2 is bigger than 1. Yes? I hope we understand that. The number that when you multiply by itself would give you 2 has to be bigger than 1, because 1 times 1 would be 1, and 2 times 2 would be 4, so it has to be somewhere between 1 and 2. So if this is house, house times the square root of 2 must be bigger. And the hypotenuse has to be the largest side. Let's practice with a 45, 45, 90 triangle. So here I will draw another 45, 45, 90 triangle. Okay, this here, the 90 degree, here's a leg and this is a leg. And let's say we know that this side is 5. Then if the hypotenuse is 5, what are the legs equal to? So we remember the relationship that if this is house and this is house, then this is house root 2. So I'm going to start with that, and I'm going to say, I know the hypotenuse is 5. That means house times the square root of 2 is equal to 5. So now I can solve for house, where house would be the side of a right isosceles triangle. Divide both sides by the square root of 2, and you get your answer. The square roots of 2 cancel, and you get house is equal to 5 divided by the square root of 2. We typically don't like writing our answer this way, so we do this thing called rationalizing the denominator, and that's basically just getting rid of the radical. So we take 5 divided by the square root of 2, and we multiply by 1 creatively. We multiply by the square root of 2 over the square root of 2. That forces this to be a rational number, 2, and the numerator now has the irrational component inside of it. So 5 root 2 over 2. That would be this side here, 5 root 2 over 2, because it was a 45, 45, 90 or a right isosceles triangle. We know that these measures here are 45 degrees, and we would know that this side here is 5 root 2 over 2. The other special right triangle is called a 30, 60, 90 triangle. And again, we'll derive the relationship even if you know it. It actually starts with a equilateral triangle. So an equilateral triangle is a triangle where all three sides are congruent or the same. And if all three sides are the same, then we know all three angles are the same. And we get 60 degrees here. And then we have 60 degrees up here as well. If we go back to geometry and I drop here a perpendicular, an altitude, I can prove that this is 90 degrees by definition of an altitude, and this is 90 degrees, so those angles are the same. I know that this side is congruent to itself, and I know that angle is this 60 degree angle is congruent to that 60 degree angle, so I can prove that these two triangles, the one I'll outline in red right here, and the other triangle, the one I'll outline in green right here, are congruent. So, because I know those two triangles are congruent, I know this is 30 degrees, and I know this is 30 degrees, and I also know that this side here and this side here are congruent, and they're half the length of this side. And this is where we get our 30-60 triangle from. We know in any 30-60 degree, or sorry, 30-60-90 degree triangle, this is 90, and this is 30, and this is 60. If I know the hypotenuse has a length of, let's say, 2 house, then I know the side opposite the 30 is half of that, or house. I could have called this house, and then I would have had house over 2, and I could deal with the fraction just as easily, but I thought it'd be nice to deal with the whole number. And now we can find the length of the 60 degree side because I know two sides in terms of the same variable. So again, using the Pythagorean theorem, calling this A, this B, and this C, we can set up that house squared plus b squared, b is that unknown side, is equal to c squared. C is 2 house, and we're squaring that whole side. So now we're just going to do some algebra here. House squared is house squared. B squared is b squared. Oh, sorry, that should be a plus house squared plus b squared. And then 2 house squared, that would be 4 house squared. Little algebra review. A lot of students will forget to square the 2. They'll just square the variable. Don't forget, inside a parenthesis, everything would get raised to the second power. Now I have a house squared over here, and I have 4 house squareds over there, so I'm going to subtract house squared. And I'm going to subtract house squared. And now I'm left with b squared, the side I don't know, is equal to 3 house squared. Just like with 45, 45, 90 triangles when we got to this point, we can now take the square root of both sides. And I'm just going to introduce that here. Put the square root here and put the square root here. What is the square root of b squared? That's b. What's the square root of 3? Don't know. It's not a nice number, so I'm just going to leave it as the square root of 3. And then what is the square root of house squared? That's house. Rewriting this, cleaning it up, we could call it house root 3. And now if I go back to my question, or if I go back to my triangle, I now know what this side is. This side is house times the square root of 3. Just like we did with the 30-60, or with a 45-45-90 triangle. With the 30-60-90 triangle, we can think of it this way. This is house times 1, this is house times the square root of 3, and this is house times 2. What is the biggest number? 2. What's the next biggest number? Square root of 3. What's the smallest number? 1. Square root of 3. That number, that when multiplied by itself, gives you 3. That would have to be smaller than 2, because 2 times itself is 4, and square root of 3 times itself is 3, and 1 times itself is 1. So I can remember that geometry relationship. The smallest angle opposite the smallest side. The next biggest angle opposite the next biggest side, and the largest angle opposite the largest side. So the relationship in a 30-60-90 triangle. 30-60-90, house, house root 3, 2 house. Good? Let's try an example with that. If we had a 30-60-90 triangle, I'm going to do my best to draw this to scale. If this is to scale, here's the 90, the largest angle. This would be the largest side. This would be the smallest angle opposite the smallest side, and this would be the medium angle opposite the medium side. Make sure we put in degrees, right? Because if we don't write units, we're talking about radians. If I knew the length of this side was 6, then I could find the length of the other two sides using the relationship that we just proved. So I know the side opposite the 60. I call that side house root 3. I can solve this equation for house. House would be the side opposite the 30, and then I can multiply that by 2 to find the hypotenuse. So over here, I would do a little algebra. If 6 is equal to house root 3, I'm going to solve for house. I'm going to divide by the square root of 3. Divide by the square root of 3. Those cancel over here. I'm left with house equals 6 divided by the square root of 3. That's an alright answer, but it'd be better if we simplified. So, over here, a little scratch work. 6 root 3. Simplify by rationalizing the denominator. I'm going to multiply by the square root of 3 over the square root of 3. Square root of 3 times the square root of 3 is 3. That's why I did it. So I got rid of the radical on the bottom. 6 times the square root of 3 is 6 root 3. Now we can simplify further. What is 6 divided by 3? It's 2. And so I get that house is also re-expressed the same number, 2 root 3. If I know house is 2 root 3, then I know the side opposite the 30 is 2 root 3. And now I can multiply this by 2. And 2 times 2 root 3, that's equal to 4 root 3. Now I have my three sides. 4 root 3 is the hypotenuse, 2 root 3 is the smallest side opposite the 30, and 6 is the side opposite the 60. And if you'd use your calculator to get some decimal approximations of these, you would see that this number is bigger than 6, and this number smaller than 6.